Good morning, students. Last time we have started first chapter, that is number system. In that we have learned about real numbers. Okay. Now today we are going to learn about laws of exponents for real numbers. Laws of exponents. This we have learned in 8th standard. Okay. So now today we are going to learn how to use these laws of exponents for real numbers. So let us recall what are the laws of exponents. Okay, we have learned in the previous classes that if two numbers are having same base and if they are multiplied, that is a raised to m into a raised to n, then at that time we add their powers. Then we have learned that if two numbers are having same base and if they are divided, then we do subtraction of their powers with the condition that the power of numerator is greater than that of denominator. Then if a number is present, above it power is present, and above this power one more power is present, that is power to power, we say that. So if a number is having power to power, at that time we multiply the powers, keeping the base only one time. Next we have learned that if two numbers are having different base and same power, during such time we multiply the base and keep the power as it is. Let us solve some examples based on these rules. Okay, our first rule is a raised to m into a raised to n, that is two numbers with same base and different powers. If they are multiplied, this dot means they are multiplied. If they are multiplied, we add the powers. For example, now 2 raised to 5 into 2 raised to 3, they both are having same base 2 and are multiplied, so we can write it as equals to 2 raised to 5 plus 3. So what we have done, we have added the powers, equals to 2 raised to 8. So this is our answer. So now a number is there, it is having two powers, that is power to power. Okay, during such time we multiply the powers, keeping the base number as it is. For example, now here it is given that 2 raised to 3 raised to 5. During such time we write 2 raised to 3 into 5, that equals to 2 raised to 15. Okay, so this is our answer. Now our next rule is that if two numbers are having same base and if they are divided, during such time we subtract the powers with the condition that the power of numerator must be greater than the denominator. For example, 2 raised to 10 divided by 2 raised to 7. Now these both are having same base, so during such time we can we can subtract the powers. So it can be written as 2 raised to 10 minus 7, that equals to 2 raised to 3. Okay, then next rule. Now suppose if two numbers are there having different base but with same power, okay, we can highlight it. For example, these numbers are having same powers, okay, but their bases are different. Okay, so during such time we keep the power as it is and multiply the base. Okay, for example, 2 raised to 5 into 3 raised to 5, it can be written as equals to 2 into 3, that is we are multiplying the power, we are multiplying the base and keeping the power as it is. Okay, equals to, now 2 3s are 6 raised to 5. Okay, then now next rule. Next we have learned that any number, that is let a be any number, if its power is 0, then its answer is always equals to 1. So the rule is that any number raised to 0 is always equals to 1. For example, 5 raised to 0, it will be 1. Okay, 3 raised to 0, our answer will be 1. So any number raised to 0 is always equals to 1. Now our next rule is, suppose that we are having a number in this way, 1 upon any number raised to power, okay, that is n. Okay, during such time if you want to bring this number in numerator, okay, this number in numerator, or if we are changing the position or place of this numerator denominator, during such time the sign of the power changes. For example, now here a raised to n is present in denominator. If we are taking reciprocal and bringing it to numerator, Okay, during such time the number comes to numerator with a change in power. For example, now we have here 1 upon 2 raised to 5. If we bring this 2 raised to 5 in numerator, that is taking reciprocal, during such time its sign, the sign of power will change. Here it was positive, now it will be negative. Okay, consider another example. Suppose we have 1 upon 3 raised to minus 7. Now here what will happen? If you want to bring this one in numerator, so we have to change its power, that is sign of power. Right now it is negative, so it will become positive, so that is 3 raised to 7. Okay, now by using these all properties we have to solve some examples. But before that, as we are learning real numbers, in these real numbers we deal with some of the numbers which are present in root form. Okay, so let us consider a number. For example, now this is a radical sign, it is known as radical symbol. Okay, now, or we can say the root. Okay, now if only it is present in this way. Okay, now here no number is there, we say that it is known as square root of 5. Square root of 5. When it will be square root of 5? When here no number is present. Okay, here we are not writing any number, means it is square root of the given number. Okay, now suppose if it is present in this way, same base number we are taking, now it is cube root of 5. Okay, suppose if we have any other number, so we can say that it is fourth root of 5. Okay, in this way, now these all are what? Real numbers in root form. Okay, now if you want to convert these root numbers in terms of exponential form, okay, so how to write it? Now suppose we have a number. Now remember that in this number, that is fourth root of 5, what is the power of this 5? Okay, so here any number is written. If no number is written, we consider that what is present over there? 1. Okay, so I am writing it in this way, that is nothing but fourth root of 5 raised to 1. Okay, now I want to write this one, or this can also be written as fourth root of 5 raised to 1. Now I want to write this number in exponential form. Okay, in exponential form, what we are doing? We are not writing this root, we are removing this root, that is radical symbol. Okay, so now what we are going to do? We are going to change this one. Okay, that is we are going to write it in exponential form. So now what we have to do? Yes, we will write it as equals to 5 raised to, now whatever power is there, actual power, okay, that we will write in numerator upon, and whatever root number is there, for example here it is a 4, so that we will write in denominator. Okay, so now it has been changed into 5 raised to 1 upon 4. Okay, let us consider another example. Suppose if we have under root 10 2 raised to 3. Now remember that this can also be written as 10th root of 2 raised to 3, that equals to, now we want to write this one in exponential form. Okay, so how to write it in exponential form? So it can be written as 2. Now what I told, this we will write in numerator. Okay, that is 3 divided by, and this number we will write it in denominator, that is 10. Okay, so I am marking it again with the red one, so this number will be in numerator and this number will be in denominator. Let us consider one more example. Okay, so let us consider another example. Now suppose if we have now it can be written as, now I'm giving you time 2 seconds, some time you people have to write it, okay, and think over it that what it must be. So what must be the answer? Yes, you got that answer or not? Okay, so it is what, 3 raised to 5 upon 7. That is, we have written this power over here and this root number over in denominator. Okay, now let us solve some examples based on this one. Okay, see, now first example, it is given as two numbers are there, 1 2, they both are multiplying but with different powers. During such time, what do? We add the powers. Okay, so it can be written as 2 raised to 2 upon 3 plus 1 upon 3. Now it can be further written as 2 raised to, now these both numbers are having same denominator, so we can directly add the numerators, so it will become 2 plus 1 upon 3 equals to 2 raised to, now this 2 plus 1 is 3, so it will become 3 upon 3, that equals to 2 raised to 1. Okay, why? Because this 3 and this 3 will get cancelled. Okay, now let us look at next example. Suppose if we have it in this way, that is, any number, its power is there. Now it is having power to power. Now remember that this 1 is present in numerator, this 5 is present in denominator. Okay, and this 4 is also present in numerator. So when we are writing power to power, during such time, what we can do? So it can be written as 3 raised to 1 upon 5. Now it will be multiplied by 4 and no denominator 1. Now remember that these two powers are multiplying each other, so it can be written as 3 raised to, now 4 ones are 4 divided by 5 ones are 5. So what is our answer? 3 raised to 4 upon 5. Now let us consider another example. Equals to, now we are having two numbers with the same base but with different powers and they are dividing each other. During such time, what we can do? We have to subtract the powers. Okay, minus 1 upon 3. Okay, equals to, now here the denominators are different, so we will take their LCM by cross multiplication method. So we will get 7. Now 3 ones are 3, 5 ones are 5. Okay, so you will get 7 raised to 3 minus 5 upon 5 threes are 15. Okay, equals to, now what number do we have? 7 raised to minus 2 upon 15. Okay, so this is our answer. Now just think over it. If I want to write this number with positive power, okay, what I should do? Okay, so what change will be there? You just think over it and you have to give me the answer. Okay, now our last example for today is, suppose if we have two numbers, okay, that is 13 raised to 1 upon 5, 17 raised to 1 upon 5. So during such condition, what we do? Yes, we keep the base 13, that is, we multiply the base and keep the power as it is. Okay, so that equals to, now what is 13 into 17? So it is equal to 221 and its power will be 1 upon 5. Okay, we can also write it as 2 to 1 raised to 1 upon 5. These both are same. Okay, so this much is enough for today. Thank you. Have a nice day.